examples, I think it's better to, if I can do it, it's not easy, but I will try to show at the same time, oh, sorry. Okay. So I will try to do at the same time the exercises and show you in the interface, so you can get an idea of what I will be talking about. So let me first, since I have this interface, let me just show what you will get when you install and load Neo4j. So this is what I was answering before. So here you have all the node labels, all the relationship types, all the property keys that are in the system. Once you do this create or import your data, everything will be here in Neo4j. And then you will have different folders, the plugin folder, the Neo4j conf folder. And one thing, it's also in the instructions that I left you, that you will, that is important, is this neo4j.conf file. Here is the configuration of the system, and each time you have you change database in this community version, you will need to stop the database, change the configuration file, and then start again the database. So the database that will be in use will be the one that is unmarked here in this dbms.default database. So in this case, we have the Nodewin AG database running. For the other example, for example, for the WebDB, you need to unmark this. Yeah?
Can I zoom in?
Sorry?
Zoom in.
Zoom in. Yeah. Okay. No, it works. So here you have the unmarked Neo4j Nodewin HG database. This is one I'm using now. Is the one for the examples that I'm showing now, and I have different databases. For the first example, you have the WebDB. If you want to run, you just unmark this and mark Nodewin AG. And Telco, which is the one I presented before, is this last one. But okay, here you have a lot of information. You need to check the website and the manuals, and just to learn everything. So here you are telling that all the plugins will be in this folder, all the data will be in this folder, etc., etc. And one thing that, so here you are saying that you put your CSV data in the import folder, and this is important since you will be using different versions, and the ones I left you are work with the one I have here, and I think that they should work with the 4.3.7, which is the last one. But just to get sure, I'm just using the 4.11.47. I mean, for sure they work. I have another computer which is Windows based. In that computer, all these databases work fine with version 4.3.47. But in the Mac, I just check with the 4.2.11. But in any case, this if you unmark this, there are two things. Unmarking this will allow you to upgrade older versions. So at some point, they should work with the newer versions of the database. And this, in this case, I just unmark this just to load in the system without authorization. But this is just the details. And there are many things related to memory management. So how much memory you assign to this to Neo4j, and a lot of things that you will discover by yourself. But these are the important ones. The allow upgrade through is one important one, and this other one that allow you to run the database. This is another. So this is one thing. Then another thing. I can zoom. With the terminal apparently it doesn't work. Okay, anyway, I want to show, I'm showing just, you go to the bin folder in where Neo4j is installed. Here I installed in the home directory, subfolder Neo4j community, blah blah blah. I go to the bin and then I run Neo4j console and it will start the database. The database I unmarked in the neo4j.conf file. Okay, and then when you get this line started, then you can be sure that the database started, and then you can stop, which is what I did after this, and then I uploaded it again. Okay, so now we have the database running. Okay. Okay, so if I write call db.schema.visualization, then I get what I showed you before. Okay, this is the slide I have shown you before. Okay, and then you can before writing queries, one thing that you can do, even with this example, is just go through the database, through the different information you have, because you need to know, since this again this is a schemaless database, you need to know what do you have what's the structure in your node. So this is the category node, this is the employee node, the region node. Okay, if you do this, you get nothing, of course. This is what you get if you click on the relationships. Okay, this is the assigned to relationship, and this is something I mentioned you the other day. There was a question, I think it was you, that asked when you ask for the relationship, you get everything that's linked to each node. This is why I clicked on contains, for example, and I get the depth I can get, and purchase, well, it depends. Okay, assign to, but of course if I click on the node, I only get the node. Okay, so you can put in the table form, or you also in the relationships you can but it's longer, of course, because you will get the node and the relationship and the node, so it will be more difficult to see. But this is what you get when you sorry, one thing I didn't mention. Once the database is started, you write localhost 7474, or this is configured by default. You can change this also in the conf file, and then you open a browser and you get this interface. Okay, so this is and here you can see the number of nodes you have, and here you can see the number of relationships. So you have 4,214 relationships and 1,293 nodes in this database. Okay, so now we can start running the queries. And where are them? Check here. Okay, so the first query is asking just to list the products and the unit price. Okay, let me see if I can. Okay, list the products and the unit price, and this is a very simple one, and I write the query here, and you run, and you get the result. What did I run? What did I write here? So I just ask to match the product here in the first instruction. So this is the matching. I just want the products. And then give me the product name, the product unit price, and order by unit price in the descending order. So this is just to show different ways of simple queries. If I write, and this is what I was always mentioning, if I write return P, I will return the whole node. you saw that it was slower, huh? And I get this. So okay, if I write directly product name, you see that you don't get the possibility of showing the graphic mode because I just asked for a node. Okay, so this is just a very simple query. So now, as another syntax construct, I am asking to list information about products chocolate and pavlova. So what I write here is again matching I match the product and I ask for the product name, and this is the in instruction that returns true if some element is in some set. Okay, and then I return p. And I get these two nodes. Okay, so just here for the syntax is the in where what I'm trying to show. Okay, so now another construct in the syntax lists information about products with names starting with a C, whose unit price is greater than 50. You know? So I write here, and this is done with starts with a statement or keyword, and the condition again is to float pay unit. I cast it to float, and I get the answer. Okay, so this is just these are just simple queries, but the idea is to show again different syntax constructs. One thing here that I want to show in this query, so the next query asks for the same as the previous one, but considering the sales price and not the product's price. So the idea here is that you get the price from the property in the relationship instead of the property in the node, right? But then the syntax is the same. But I want to show that here what you get is C dot unit price instead of P dot unit price. So there are some cases in the database in which the unit price of the sale is not the same as the unit price of the product. So the list price, so to say, right? And then I get this. As you can see in this example, the product was sold with a different price than the list price of the product. Okay, so this is what we're getting here, and okay, another query. Okay, now these things. So I want the total purchase by customer and product. So this is a typical analytical query, a typical Oracle query. And in this case, okay, for now forget about the optional at this moment. What I'm showing here is that what we get is first the matching of the sales. So this here we are saying the order was purchased by someone, and the order contains some product, and I want the total by customer and product name. So what I'm doing here is I'm multiplying the unit price by the quantity of the product, casted in different ways. Again, because this is because the way in which you can see here the quotes here. So this is why we need to cast first. So then we get this total. Now I'm going to get into the optional. Okay. So here is this is an aggregation query, an aggregate query, right? We're getting the total sales by customer and product name. Why do we write customer here, optional here? Remember that the optional was work like an outer join. So if there is some product that is not purchased by anyone, then we will get a null, and we still get the result. So if we don't write, in this case there are only 2 cases, but then I will show you an example in which this optional is more relevant. But the idea is that if we don't match, if one of the ends don't match, we still get the matching there, and you can apply you can get the result. So you don't lose any tuple, so to say, because for example, if you need to count that this is not relevant in this case, but if you need to count, then it will become relevant to get everything and not just the matching elements. Okay. So let me skip this. This one just has the limit condition is nothing important. But now let me show this collect statement that I mentioned the other day. So I want for each employee the assigned territories. For this, we use this statement called collect that performs an aggregation, but instead of applying a function, an arithmetic function, we aggregate this in a list. So what I get here is the name of the people and a list of all the territories that he or she are assigned to. And as I mentioned the other day, this is important because sometimes, especially in analytical queries, sometimes you will need to make lists, aggregating elements in a list, apply some function, which are very useful, some list functions like give me the head or give me the last one, the tail of a list, the first element in a list, the count the elements in a list, etc., etc. And then there's another statement which acts as the inverse of collect, which is called, I don't have here, there are, I think in this list, in this exercises, this is not mentioned, the unwind property. So the unwind is flattens the list, so it's like nest and unless in SQL. And normally you use collect and unwind together. You first collect elements in a list, apply some function, and then apply an unwind, so then you get again a table.
Sure.
Yeah.
How is this different from group by, the collect?
Is
it like a group by?
No, group, I mean,
aggregation?
yes, but the collect, you see here the result.
Yeah.
So, but you don't, in the group by you cannot make a list.
Yeah.
In a group by you group by, in this case, you group by employee, last name, and then for example, suppose I say all the sales of the employee. I get the employee, and then an aggregate function like sum, average, etc. apply to all the elements.
Okay.
But in this case, the collect builds a list. Okay, this is the difference. I mean, with the group by you cannot do that. I mean, in any case, group by doesn't exist in group by is implicit in.
Can we do this in
inside.
SQL?
Sorry?
Can we do this in SQL?
Yes, you have,
Yes,
for
yes.
example, array in PostgreSQL.
Yeah.
There is a function which is called array_ag for aggregate. So you have a group by, and then you collect in the list all the elements of the group by.
Okay, so here you can see you have every element, every employee, and a list of all the territories he or she are assigned to. Okay. And then again, this is similar to the former one. For each city, list the companies settled in that city. This is similar to the other one. Okay. This is the same for each city, all the customers. But again, this is normally used as part of some other query because you need, for example, to do cumulative sums. It's very useful to use collect because you traverse the list and then you perform the cumulative sum, and then you unwind and get the table again. But these are more complex queries. And okay, so I want to come to this problem. Remember the problem we studied last Monday about computing the transitive closure of a relationship, in this case the reports to relationship. Remember that we used the SQL recursive queries? Okay, and I told you that it was all that complex recursive SQL query can be written in one line in Cypher. And this is the case, actually. So here you can see this statement allows you to compute all the paths between two employees. You just write reports to star and finds you the transitive closure of the reports to relationship, right? So here I'm asking how many persons an employee reports to, either directly or transitively. So this is the transitive closure of the reports to relationship. But this query has some things that I want to comment you, because they have to do with the semantics of the language. So this is the query. The query will get you this. Fuller reports to no one because it's the boss, and then the other ones report to one or two people. Okay. So this is the query, say, written in the right way. But suppose that I do this. What will happen? So now I'm not. So these are two matches. The first match matches all the employees, okay? The second match matches the reports to relationship between any pair of employees. What would I get if I comment? So this double slash comments out the line. So what do I get in this other case? So the problem here is, you see what we will get. So what is missing here?
Fuller?
Fuller is missing. So the boss is missing. And why is that?
Because he doesn't report to anyone.
Exactly. So there's no match. So this is why I need first to match all the employees, because otherwise I will miss the boss. So, and this is important. If you write just, if you omit this first match, you will get the wrong result. I mean, the result will be right, but you will be missing the boss. Okay, and this is why I wanted to show this this example. And let me show you. So then I want to know to whom do persons called Robert reports to, and in this case, I'll do this. This is similar, but I'm telling, I am asking any kind of reports to relationship, and but I'm asking that the supervisee to know to have the name Robert, and then I get the same thing. Okay, this is the answer. And another thing here is who does not report to anybody. Then this allows me to show you another syntax thing. So this is the where not. So give me all the employees. So first I match all the employees, and in this case I don't need the transitive closure. I just ask who doesn't report to anybody. So in this case I just say and we get soon. Fuller is of course the boss, so he doesn't report to anybody. And this is done with the where not statement. Okay. So
In this case, if you had skipped the match employees, would it still return Führer?
sorry if I
Omitted the match employee.
no, but this here we have only one match statement. So if I miss the match, I will get a syntax error because there's only one match. Because here I'm not using the star. I'm not using the transitive closure because since I just want the people who doesn't report to anybody, I don't need the transitive closure. I just need the reports to relationship. Okay, so then for the other queries, there is simply just a side. But before we finish, let me show you this other problem that you will be solving. And now we can use this. Okay. So all the other you have the answer for the other queries, but nothing very difficult there. But I want to comment on this other example. Okay. So once we finish with the other example I have left you is again the Nordwind database, but now not in the form of the order details, not in the say OLTP form, but in the OLAP form, so in the as a data warehouse or a data map. So now we have the same information, but organized in a different way as a data warehouse. So instead of having orders, we have sales. Okay, and I want to describe the problem because you will need to work on this later. So what I have here as are the sales, and I'm saying here that a sales fact was handled by an employee, was supplied by a supplier, was purchased by a customer, and was shipped by a shipper, and contains a product. So we have, say, a sales fact contained instead of an order line, a line order, and then we say that these products are aggregated along categories, and that cities are in a state, contains, I think it says. The sales, the state belongs to a country and the country to a continent. And there is this recursive relationship. And then we have three dates here. The shipped date, the order date, and the due date. So we have this information organized as a data warehouse. And since we have some time, I will show you how you can do this thing. So now,
how was the HG database? How was it organized?
I will show you.
Sorry,
I will show you now. This is where I want to do this now.
So maybe if Adam, the previous one was the OLTP database, and this one after the ETL process, then we created the data warehouse.
Thank you. What does HG stand for? Is that some sort of an industry lingo?
No, HG is just hypergraph. I mean, it's the name I gave
Okay,
it.
hypergraph. Thank you.
So now I stop the database, and now I have the neo4j.conf file. The neo4j.conf file changed. Now I run. This is what you are going to do when you change databases. Okay. So now we have to wait a little bit until the database is loaded. So this is what you have to. You will go through when you work with this. Now it's loading. It's starting. The database is starting now with a new database. Yes.
You can select from the use database on the
No, you cannot change it. It's
You
not,
can, like-
these are the databases that sometimes were used, but it's not that I just go here and that is done. I need to stop the database and
This is how
start
I
it.
am doing.
or I can. This doesn't work.
Okay.
You need to wait until this database starts, and I hope it does it soon. It used to be faster. Okay, here it's starting. Okay, and now it's starting. Now the database is starting. We go, and then since I don't need an authentication, I'm connecting, and hopefully this will connect, and we will use. Okay. And now we have the Norwin data warehouse data. So here we have sales. No. So now we have the other. Now we have the Norwin data warehouse running, and we're asking. This is the structure now that this is the Neo4j, the Norwin data warehouse database now. So we have sales, and instead of you see here you have the order line number, unit price, but the database is organized in a different way. So this is called in OLAP jargon, it's called a sales fact, and then we have all the dimensions that in the same way as I show you in the telco example. So we have here we can see call schema visualization, and now we have the schema of the database. So this here is the sales fact, and we have all the information. So and then you can check by yourself the structure of this data warehouse, but we have two ways of viewing the same data or the same same things. This is more appropriate for data analysis. The Norwin AG is more appropriate for OLTP kinds of queries. And I also wanted to show you how you work. I mean, so the sequence is you stop the database, you unmark the database you want to use, then you start again, and you get this, and you are running again. Okay, so and then you will see, and I will not go through all the queries, but now you can see that the queries that I'm asking for in this other example are more analytical queries. Give me the total sales amount per customer, year, and product category. So this is kind of an OLAP query, like a group by query that you do in SQL. I'll show you just this as an example. So what I do here is I match the sales fact analogously that what we have done with what we have done to what we have done in the telco example with the phone calls, right? This is the sales, and then you go through the customer dimension, through the edge purchase by, and then you go on the other way, you go along the product dimension up to category, and then I just return the company name, the category name, and the aggregation again, and you don't need the group by clause. So and then you get this result. Okay. So then you will do the exercises. I don't know how are you going to work with them the other week with the Norwin example.
We will.
So because we have two options. We can work with this example on Thursday, or I can do the Postgres and the more graph-oriented queries on Thursday with them in the lab, and then you do this Norwin. I think yes. Someone asking the question. Okay, so the idea is with this we finish the lectures, and the idea is on Thursday. The good thing would be if when you get to the lab, you already have the Postgres graph loaded, and and the how was it called, the mini graph web, mini web graph, web graph 3, I think is the one I left you on Cypher. So we will work with this web graph 3, and then you have mini web graph. I think it's
Mini graph web.
mini web wave or something. Yeah, 1, 2, 3, which are graphs of different sizes. Yes, just a minute. So
Please.
in the first activity, we will use these 3 graphs of different sizes, and we're going to write queries computing typical graph algorithms, so paths and so on. And then I will show you, or you will see, that the transitive closure is a hard problem because when the graph turns a little bit larger, it will not finish. And then, with the largest of these graphs, you are going to work. You will be doing the same things, and we'll see what happens. Yes.
So is it possible to send an email with all the details of the installation? So
You already have them.
Are you registered into? I sent an installation instruction just now, and you have received a zip file with all the databases few weeks ago.
I think that there was one more that I created. Maybe we will check, and in that case you can send it today or tomorrow.
So the idea is that, of course, we can have we are installed the machines in the lab machines, the graph. But typically, since you can do it on your own PC, you can test. So it will become more easy if you have it already, everything running, to work on your own PC.
Yes, I will
for
suggest
Thursday.
that.
But we will be doing that on the lab session on the UB4. Question?
Yeah, so sorry, just to be really, really clear, we are not doing any Postgre on Thursday. We are doing only Neo4j.
Yes.
No, Postgres, yes. We will be doing two, both.
Okay.
Postgres and Neo4j.
Okay, so that means that I need
Activity
to,
1 is Postgres,
yes.
activity 2 is Sulfur.
Okay.
So we will try to do both on Thursday.
Okay, so that means that I need to have Postgre installed and running.
Yes,
I need to have Neo4j installed and running.
yes.
I need to have WebGraph 3 loaded. I
And
need
the
to
other,
have
and the
mini
three
WebGraph
and the
3.
3 databases and the 3 tables, Minigraph Web. I don't remember the name. You have 3 CSV files, 3 text files, and there are instructions
Okay.
in the activity. You have the copy statements to copy the files,
Okay.
the text files, to create the tables in the database.
And WebGraph 1, 2,
Yeah,
and 3
exactly. WebGraph
need
1.
to be put into the Postgre.
Exactly,
database.
into the Postgres database.
And WebGraph 3 and MiniGraph Web need to be put into Neo4j.
Yes, everything that's in for Cypher, it was that you have in the you have the yes, exactly, because you don't have the files exactly. Yeah, WebGraph 3 and it's for Cypher. Yes.
So one question, the idea is that you prepare everything if you have before Thursday, and if you have any question, please send me an email, and then I will try to answer the question. Yes, Andres?
For the Postgres installation, is there like any particular version that?
No. It's very simple. Anyone will do. Yeah.
You have mentioned all the instructions in the document as well.
I think you have everything done, but if you have any problem before Thursday, please send me an email. I will try to help you on that.
Yes, and also in the activities you have all the instructions, so you have the steps to load databases.
So try to be, as you know, we were not able to find a slot in which do a single lab for Postgres with Graph and another lab for Cypher. So we are trying to mix the two, but for this we need your help, that you have everything installed to begin immediately working.
Yeah, so we can get all the time. Yeah.
Okay? So until Thursday, have a nice week.
Next week, see you on Thursday.
Okay, so stop all work on projects.